Okay, this section is percentiles and box and whisker plots. So we're going to interpret, describe box and whisker plots, and then everything that's entailed with them. The first thing I want to talk about is percentiles. Now, you guys may be looking back at taking your NDSA tests or ACT tests or Iowa Basic tests or whatever tests you've taken before. A lot of them are given in percentiles. They might give you a show in there. I just realized that I have a misspelled word, so that's pretty cool. I should probably fix that. But anyway, percentiles are all about the position that you're at to the rest of your peers. So in a heavily skewed or bimodal, this is maybe a better representation if everybody's kind of clumped together. You want to see where you're at in position to everybody else. So percentile is the percentage of data that fall below it. So an example is this. If you have a psychology midterm and you're in a 73rd percentile, that means 73% of the scores were below yours. Or if you flip it up, 27% of the scores were actually above yours. It's your percentile. It has nothing to do with the, well, it has something to do with the score, but you can't necessarily give yourself an A or a B or a C with this number. It's gauging, what percentile you're in. So in this example right here, 40%, if you're in the 40th percentile, this is what they show as percentile is 40. Okay, 40% of the people fall below you. Now you maybe still got an A on the test, but 60% of the people in your class were above you, if you want to think about it that way. So that's the idea of percentiles. There'll be a couple questions on the homework that involve that. Special percentiles. This is where quartiles come into play, and this is where we get our box and whisker plot. So you need the lowest, the highest. They're pretty easy to find. And then the median is your middle number, your second quartile. That's the first thing we'll find. And then we have what we call our quartile 1 and quartile 3. We're going to use those to find the interquartile range, and that's how it's labeled, IQR, interquartile range. It's the difference between the third and first quartiles. The first quartile is 25th percentile, third quartile is 75th. Think about quarters, that should be pretty straightforward. So computing these quartiles, the first thing you must do, obviously order it smallest to largest. You're going to need to know that in order. Find the median. Need to have that first. The median is the first thing you find, and then you will basically bust your whole entire data set up into two chunks. The numbers that fall below the median, then you'll find that median. There's a lot of medians going on, which will be your first quartile, and then the larger chunk of numbers above the median, you will then compute the median of that set of numbers to find the third quartile. So just a concrete example to figure this out. And I did not move that back up, so I kind of gave it away already. Okay, so here are the, how many numbers do we have? 1, 2, 3, 4, 5, 6, 7, 8, 16. I have 19 numbers in this data set. All right, now how do I find the median? You can either start crossing off first, last, and find the middle, or you could use the position thing. So 19 plus 1 over 2, which is 20 over 2, or the 10th number in your data set. So 1, 2, 3, 8 on the top, 9. Here's your median. Okay, so the median is 24 in this data set. Once that is established, you will not use that number again. So that's your starting point. Now, how do you find the first quartile? That's what I'm doing on the very bottom. I'm only looking at these numbers below the median. So the 12 through the 23. I want to look at just those numbers and find the median of those numbers now. So I have, what, 8, 9 numbers. So if I have 9 numbers, the position is the 5th number. Or if you start crossing stuff up, you should see that the 17 is the middle number. 4 below it, 4 above it. And then that would become your first quartile. So for the data below the median is 17, which becomes your first quartile. And then to find the third quartile, it's the same idea. Do not use the median. That's already established. So I use a circle there, and I only look at the numbers above it. And the same concept, it should be the same thing. I should have 9 there as well, and then it should be the 5th number. So 33 is your third quartile. So it's all about finding essentially the median 3 times. Once you establish the median of the entire group, split in 2 chunks. That's how that works. So the interquartile range is pretty easy. If your median is 24, okay, and then you just take your first quartile, actually third quartile minus first quartile. So 33 minus 17 is 16. That tells you that 50% of your data, the middle 50% of your data from the first quartile to the third quartile is 16 apart. It doesn't matter kind of the concept of the question. It's just they're 16 units apart. Now, all of these major numbers, the lowest, first quartile, second, third, and the highest value, we call a 5-number summary. These are the ones that we use to build a box and whisker plot. So to do this, now this is kind of misleading in a way. They only say vertical. It can be horizontal as well. It's strictly dependent upon what you want to do, because the calculator will do it horizontal. I have a bunch of vertical ones. I don't want to say only vertical. You can do it however you wish. You need to have a scale, essentially a number line that has consistent increments. I don't want to just see the 5 values that you have in your 5-number summary. Give me a consistent increment like you're graphing a line. Okay, to the right of scale, you draw in your 5 numbers, and then they're going to become the whiskers, and I'll show you how to do that in a little bit here. So, going back to our problem, we found that we obviously can see that the lowest number is 12, the highest number is 51, and then we found the 24 is the median in our 2 first quartile and our third quartile. So how do we build this? So this is what I was talking about. We need a consistent numbers here. So going by 10s, 15, 20, something like that. You can go by 2s, you can go by 5s, 10s, just make it consistent. I do not want to see just these 5 numbers on your graph. I want to see a nice number line, basically. And then how does this work? Well, your lowest, your highest, okay, your median, notice your interquartile range is the box, and you just plot them on there, and then the whiskers come out from the third quartile to the edge and the first quartile to the edge, and that becomes your box and whisker plot. And then you notice that your median is actually a little bit closer to the lower values. So they seem to be a little bit more scrunched towards the lower numbers. Higher numbers are kind of spread out a little bit more. And that's what you can kind of look at when you do this. So a quick glance, and I kind of chatted about this already. The box tells us where half the data is. Okay, so in this case, between 17 and 33, the interquartile range is 16. So half of our data is in that box. So it's pretty swooshed together there. The median is closer to the lower part of the box. I just kind of talked about this. This means the lower numbers are more concentrated. They're closer together. Or if you flip it, the upper numbers are more spread out. It's slightly skewed to the higher numbers, where your tail spreads out a little bit more. Upper whisker is longer than the lower. Notice that what I mean by that is this whisker is longer than this one. So the same amount of data is falling in this one, same number of data points as that one. It just takes a longer number value to get there. Okay, so there's still 25% of your data down here, still 25% of your data up there in that whisker, but it's just the distance from 33 to 51 is longer than 12 to 17. Okay, here's another example. I just want you to try it. So if you could push pause, that'd be good if you want to try it and see if you follow along with me on that. Okay, if not, okay, you want to order them, lowest to highest. And then you need to compute the 5-number summary. So you have to find the median, and I believe there are 22 numbers. So your median actually falls exactly between 209 and 234. So to find the median in between two numbers, you have to find the average of the two. So the 209 plus the 234 over 2. And that's going to give you 221.5. So I know my median is actually 221, which falls between the two. Alright, now that's going to bust your data into the top row and bottom row for the lower half and the upper half of your numbers. So now I need to find the median of the top row. To find the median of the top row, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 numbers. So I need to find the 2, 3, 4, 5. I need to find the 6th number. That should be the middle, 5 above and below it. So there's your quartile 1. And then 5 numbers, 1, 2, 3, 4, 5, 6 number here. So this should be your quartile 3. And then obviously you can know that 111 is your low and 439 is your high. So there's our 5-number summary. And then you need to just draw your box and whisker plot. Now I'm going to let you guys do that. Just build a line, and whether you do it horizontal or vertical. And then you obviously need to cover from 111 to 439. So I mean, you could go by 25s, you could go 50s. Maybe we'll go by 50s. So 100, 150, 200, 250, 300, 350. And you can make these whatever you feel like doing. And then lowest number, 111, which is going to be about right there. 182. I have my median is 221.5. Have my 319. And then I have my 439 as your high. So then I want my box. Oh, that's not even close to straight. You can make fun of me for that. That's quite alright. Your whiskers go out and you need your line at the median, and that's kind of the idea of what it looks like. Now you can go ahead and write the numbers in up here. The 111, the 182. That sometimes helps, just have you solidify what the numbers are, but I do not only want these numbers up here. Now what I want to do is show you on the calculator actually how to do this. So if you go in and dump your numbers into a list, so if you go to Stat, Edit, I believe I've already done that in List 3. So now if you go to Stat Plot and you push Enter, you need to make sure you turn it on. So I'm going to turn it to on. You need to find, like this thing that's highlighted where we did our histogram, you need to go down and do the box and whisker plot. It's the middle one on the bottom row. And push Enter. It'll tell you what list you want to have your data in. Now I believe in mine it's List 3. You guys might be able to put it in List 1 or 2 or wherever you want. I put mine in List 3 so that it was quicker. Okay. And now you need to turn to your window. Now how does this work? Now I already have mine set up, and if you look at the graph here, it's telling me what's going on already. But the lowest number you need to have just below your lowest data point. So we had 111, so I'm going to make it 100. The X max is the number you want, and it has to be above your highest data point. So I put 450 because it's just above 439. It's irrelevant. You can do whatever number you want. Now Y minimum, your box and whisker plot's going to show up above your axis. So I put my y-axis, or my y minimum of -1, and then my y max of 15. You can make it 50. You can do whatever you want. And if you push graph, it'll pop up. Now if you want to do this and not do your interquartile ranges and all that stuff, then you push the trace button. So this is kind of just like the histogram stuff. You can go through and notice on the bottom it gives you your median, your first quartile, your lowest number. So this can happen as well. Okay. Now also you can calculate. So let's go back to Stat, Calculate, first variable statistics again, and now I have all my information in List 3. Here's another way to check your work. If you get all this information and you scroll down, the 5-number summary is given to you. So you have your ends 22 numbers. There's my minimum, my 182, the 221.5, the 319, and the 439. So the calculator does this for you in the first variable statistics as well. So notice that that happens quite often. It's there for you in quite a bit that we have to use that. So that's just to show you what to do with the calculator. Let's go back to the notes. Oh, by the way, you might want to make sure you title your box and whisker plots as well. That's should be known by now, but just make sure if you put any graph together, you title it. So the number of computer sales per month in the last year. Let's say we have Angela and Carl. Compare them. Just take a minute and see what you think. Is there something obvious that you can take out of this? Hopefully you maybe can see it. So here's what I notice. Carl's highest and lowest scores both are higher than Angela's sales. His high score of the month is larger, and yet his lowest is still better than Angela's lowest. Carl's median is also higher than Angela's. Okay, Carl's interquartile range is larger. Now that could be an argument. Maybe she's better because she has a lot more data within the middle, where he's spread out more. I don't know, you could argue a lot of different things. The only thing that Carl's really lacking is that interquartile range is a little wider, and his first quartile is lower than Angela's. At the same point, when your highest number is better, your 75th percentile is better, your median's better, and your lowest is better, you probably could argue that Carl consistently sells more computers than Angela does because of this. So you may have to compare these, and that's what you're looking for. You want to compare the similar percentiles and see if there's anything happening. So that's just an example of that. A few variations. Fences placed on either side of the box to represent various portions of data. This happens more so in Minitab than anything. Outliers, we should talk about this a little bit now. In these particular problems, I've mentioned outliers quite a bit, and how do you calculate what deems an outlier, or what can skew data heavily. This is what we do to find an outlier. We take the interquartile range, and we do not want a number to be 1.5 times either way of our first and third quartile. So for instance, on this last example, if we had an interquartile range of the very first example was 16. So if you go 1.5 times 16, that's going to be like 24. So if you add or subtract 24 from the first quartile and the third quartile, if there's a number that's outside of that, either way, we would then throw it out. So in Minitab, some of these computer programs, we don't use Minitab, but they'll mark it with an asterisk, but we'll throw it out. So that's an idea of how to do that. I know one of our problems in our homework asks you to do this, but that's what you need to do. Go 1.5 times your interquartile range and then subtract it from the first quartile to see if there's any numbers below or outside of that. Essentially your lowest number, is it farther out than that? And then you would take your interquartile range times 1.5 and add it to the third quartile and see if like your highest number is beyond that. So that's the idea of an outlier. That's how you mathematically can figure that out. So then in class tomorrow we'll do these couple problems. They do not take very long, and then we'll start reviewing and get ready for our test. Hope you guys have a wonderful day. Oh, actually, yeah.